Hello everyone, welcome to the presentation called The Art of Investigating Problems in Software. Let me first introduce myself. My name is Szymon Sadowski. I'm a lead software engineer at Sabre, a travel technology company, where I spent the majority of my career. And working in a diverse domain as travel is, I had the opportunity to work with many different libraries, frameworks, technology stacks, you name it. And this combined with the tendency to jump right into the action hands-on resulted in me developing some techniques of investigating problems in software, regardless of the technology and regardless if you are an expert in the technology or not. So let's also talk about some motivation, what motivated me to do this presentation. So I actually must say that I love debugging. So you must think probably to yourself that, well, that's one of the craziest things I've heard in a while, right? But bear with me for a second. I like debugging because I feel like it's something that makes me learn the most and the quickest. So let this be my first tip for you. Enjoy your debugging sessions, right? So we often tend to get frustrating during long and tiresome debugging sessions when we seemingly do not make any progress towards the original goal. But please keep in mind that we are, after all, improving ourselves. We are gaining experience in the kind of the problems that we are working with. We are getting to know the system that we are working with better. We are getting to know the tooling better, the particular technology. And last but not least, we are also improving our patience. So there's that. There's always a bright side. So with equipped in this positive mindset, let's jump into a few real-world cases that hopefully can demonstrate that debugging can be indeed fun. So case number one, we have a web application where some characters outside of the Latin alphabet are displayed incorrectly, as you can see. And for the sake of the presentation, let's assume following flow that text takes before landing into the database. So we start with the front end. We send the data from the front end to the gateway service, and it goes through a couple of services. At the end, it lands into the database. And the retrieve process is exactly the same, but in reverse. So if I would ask you how would you approach this problem, you would probably naturally find yourself applying the following technique. So you would start with the front end to see if the text is saved well in the memory. Then you would see if maybe during the transfer between front end and gateway service, it got corrupted. Maybe there's some processing in the gateway service that corrupts the text. And you go step by step. You check each of the transfer parts and each of the components. At the end, you check if it's well saved in the database. If it is, then you check exact the same process in the reverse, the retrieval process. And at one point, you would probably find that, hey, in this component or during the transfer between those two components, something goes wrong. So to call it an official name, this technique, we can call it the problem isolation. So it's good to start with this question where you're debugging some problem which spans across multiple components of your system. So start with asking this question: what area of the application the problem happens? Is it a Lambda function? Is it the ETL process? Is it the backend? Is it front end? Is it a database? Where does it happen? So we can sometimes find some clever ways of narrowing down the problem. For example, you can try and substituting one of the components. And if you consider that the problem still occurs in the same nature even after you substituted the component, that means that with a high certainty, this component doesn't contribute to the issue. So this means that you further narrowed down the problem. So it's important to be clever and find ways and invest this effort into further narrowing the problem. Another real case of this application is in the network OSI model that you might be familiar with. So it's a standard model for network communication where you have several layers. And if you are investigating a generic network problem, you can use it to your advantage. Let's say you are investigating a generic problem of lack of internet connection, right? So you start with the physical layer, you check if the cable is broken or disconnected, you try swapping the Ethernet cable to another one. If you rule out this layer, you go up on one layer up to the data link, you check your VLANs. If you rule out this layer, you go one level up into the network layer, you check if it's a problem with routing. At one point, you will say, hey, I know that this happens in this layer, so that means that you save a lot of time and you can just focus your search inside this one layer. And it's commonly used among network specialists all over the world. So speaking about networking issues, let's jump into the case number 2, investigating authorization issues in Lerna. Well, Lerna, if you're not familiar with, is build system for JS monorepos, basically. And one time I was trying to set it up against the internal NPM registry of my company, and I was getting at all times the unauthorized error whenever I was trying to do something. Even though I followed the official documentation and tried many different configurations, and it was to no avail, I still couldn't figure out why it happens. So I decided to take a look under the hood and use this low-level debugging tool, Wireshark, to investigate on the low level the network traffic that was coming out from my local machine to see what's going on. And it turned out that Lerna was not doing any authorization at all. I couldn't see any headers, authorization headers, nothing. And at the end, it turned out that it was a problem in the range of the versions of the Lerna, so I had to apply some workarounds and wait for the fix. So the lesson for that is to not be afraid to use these low-level debugging tools, even though they may look scary. So staying on the topic, case number 3, one time I was investigating a Maven build issue in a large project, way over 500 modules, and we see this error, duplicate project exception for one of the modules. Essentially, it means that one of the modules is included more than once in the reactor build tree. And it may be really difficult to trace down exactly how 2 modules are imported more than once, maybe twice, in such a large project, because with such amount of modules, the amount of possible import paths are endless. So, it's fine. Maven tells us what the issue is, but doesn't tell us in what places the project is duplicated. So if it told us from the start where the conflict happened, we could straight away solve the issue. So what we can do is we can take the matter into our own hands and find it out for ourselves. So let's formulate a plan of action first. It's also good to formulate, if you're investigating some complex issue, to formulate a plan of action to stay organized and record what have you tried so far. Also, formulating such a plan can spark new ideas. So the plan of action will be as follows. We'll download the Apache Maven source code, we load it into the IDE of our choice, and then we will, in our CLI, run the mvn debug command, which will expose the port for remote debugging. And then we can attach from our IDE to this remote port and start debugging and gathering information by ourselves. So before we do that, let me discuss some capabilities that I find useful in the debugger. I really encourage you to explore. There are many of those, and still new capabilities are being implemented. So particularly the exception breakpoint and catch clause filter and drop frame will be useful in this case. exception breakpoint and catch clause filter, we can straight away set it for the exception that Maven communicated to us, the applicate project exception. And also it has advantage over like setting a breakpoint inside a catch clause, because it will stop at the line where the exception is thrown. So at this point you can see all the context, all the state of the application that was there at the moment where the exception was thrown. So you have all the context that lead to some error, right? Whereas if you stop at the catch clause, you lose that information. And another one really useful is drop frame. I like to call it time machine capability, sort of. You can essentially ditch the current function execution and go back to the place where function was called. So essentially, it's useful where you deemed that, okay, it's too late, I missed my chance to see something. In that case, you can drop the frame, you can set the exception breakpoint once again in the place that is interesting for you, and you seem to be able to find something there, and resume the execution. So at this point, you will see this information. You don't have to rerun the entire process once again. You can drop the frame and you essentially go back in the execution flow. So applying those techniques, we'll quickly arrive at this place, default project builder in Maven. And to me it's amazing. We can already see on the left that there are some recursive calls, and they will unveil the import paths that are conflicting. So watch the red arrow. This is the first import path, like this. And the second one is gonna be like this. So it's indeed a conflict. So at this point, it's just a matter of trying to remove the module inclusion from one of the parent modules, of course, ensuring that the necessary dependencies and functionality is still there, and your problem will be solved. So also one lesson learned from this is to not be afraid to dive deep into the code, even if it's an external library. It looks scary, but it's not in reality. Case number 4, investigating the necessity to have kill capability in Kaniko. Kaniko is a tool to build Docker images from Docker files inside Kubernetes cluster. And at one point at my team, we were trying to apply some security boost and drop the kill capability. So essentially, this means that in this container, the real or effective user ID of the process sending the kill signal will have to match the real or effective user ID of process receiving the signal. So in other words, basically, you won't be able to kill not your own processes. And after we dropped this capability, it turned out that Kaniko failed to perform its function. It failed. And it was really interesting why Kaniko needed such a capability of killing not its own processes. So plan of action here is kind of like just the brute force, pulling out the big guns, using strace, which is a tool to trace and intercept and record system calls and processes sent to the signal. So we can attach to the Kaniko process and look at this beautiful logs. But after digging a little bit deep into these logs, we'll come to the conclusion that the situation is as follows. So in the Docker file, if you have a run command, and let's say it's a run A, and it spawns a daemon process B, then this daemon process B has a different effective user ID. And essentially, at the end, when Kaniko stops the execution, and when it's cleaning up, it's trying to kill those processes. It's trying to kill essentially the process with a different effective user ID. So at this point, it's just a matter of mitigating that, and that's it. So some key takeaways that I would emphasize from this presentation to answer the question what it takes to be a great software detective. In my opinion, the first one is enthusiasm. So let's keep the positive mindset that we are getting a lot of value at all times. And the second one is courage to not be afraid of looking down under the hood and using scary tools. That reminds me of some demotivator, or actually a motivator from a while back. So courage is where you go where everyone is running away from. So I took the liberty to adjust it a little bit to our industry. It would look like this probably. So yeah, that's it. So thank you everyone.